The ketogenic diet, characterized by high fat, very low carbohydrate, and moderate protein intake, initiates a profound shift in the body's metabolic state from glucose dependence to fat-derived ketone utilization. This metabolic switch not only provides a steady energy source during carbohydrate scarcity, but also triggers cellular stress response pathways that promote autophagy. As glucose availability drops and insulin levels decline, the body enters a state of nutritional ketosis, producing ketone bodies like beta-hydroxybutyrate, BHB, that serve as both fuel and signaling molecules. BHB, in particular, has been shown to activate SIRT1 and AMPK while suppressing mTOR, a powerful autophagy inhibitor. This triad of metabolic regulators orchestrates a broad transcriptional response that encourages the breakdown and recycling of cellular debris, worn-out mitochondria, and misfolded proteins. As a result, the ketogenic diet doesn't merely sustain energy levels in the absence of carbohydrates. It enhances cellular housekeeping mechanisms that preserve function and resilience under metabolic stress. This effect is especially pronounced in tissues with high energy demands, such as the brain, heart, and skeletal muscle. In neurological contexts, for example, ketogenic diets have shown promise in reducing neuroinflammation and improving mitochondrial function, in part due to increased autophagic activity. The brain appears to thrive under ketone metabolism, benefiting from improved mitochondrial biogenesis and more efficient clearance of protein aggregates, findings that are particularly relevant in the context of neurodegenerative disorders. Beyond the brain, other organs also undergo enhanced autophagic turnover, contributing to better metabolic health, reduced fat accumulation, and even potential protection against certain cancers by removing pre-malignant cells before they can proliferate. To support autophagy on a ketogenic diet, the type and quality of fats consumed are essential. Medium-chain triglycerides, MCTs, found in coconut oil and available as concentrated supplements, are rapidly absorbed and converted into ketones even in the presence of small amounts of carbohydrate. This makes them particularly valuable for individuals transitioning into ketosis or seeking to enhance ketone production without prolonged fasting. MCTs not only elevate BHB levels quickly, but may also independently influence autophagy through their effect on energy metabolism and mitochondrial stress. Omega-3 fatty acids, especially EPA and DHA found in fatty fish, flax seeds, and algae, also play a supportive role. These long-chain polyunsaturated fats possess strong anti-inflammatory properties and can modulate autophagic activity through multiple mechanisms, including PPAR activation and inhibition of inflammatory cytokines. They help maintain membrane fluidity, improve mitochondrial dynamics, and may prevent the accumulation of oxidative damage that necessitates autophagic repair. Consuming these fats regularly complements the regenerative effects of ketosis by creating an anti-inflammatory, lipid-balanced environment favorable to cellular renewal. An often overlooked aspect of ketogenic eating is its natural reduction in glycation and oxidative stress. With less glucose available to non-enzymatically bind proteins and lipids, there is a reduction in advanced glycation end products, AGEs, which are harmful to tissues and require autophagic disposal. Additionally, ketosis reduces the need for insulin secretion, thereby lessening the anabolic push that typically inhibits autophagy under high-carb conditions. The combined effect is a lower metabolic burden on cells and a tilt toward maintenance and repair. For those seeking to optimize autophagy through dietary intervention, the ketogenic approach offers a metabolic landscape that mimics fasting without complete caloric abstinence. It brings together the benefits of insulin suppression, enhanced mitochondrial efficiency, and cellular recycling in a way that is both sustainable and deeply rooted in evolutionary physiology. Whether practiced cyclically or chronically, the ketogenic diet represents a practical strategy to harness autophagy for improved energy, cognition, and long-term cellular health, especially when supported by thoughtfully chosen fats like MCTs, omega-3s, and unrefined coconut oil.